Hello, science fact tech community, and welcome to our channel. For centuries, humanity has gazed up at the night sky, mesmerized by the twinkling stars and distant planets. We've dreamt of rockets, spaceships, and boldly going where no one has gone before. From the daring Apollo moon landings to the tireless Mars rovers, our journey into the cosmos has already begun. But what's next? How far can humans really go? Will we set up camp on Mars, mine asteroids for resources, or even find evidence of life on some distant moon? These aren't just questions for science fiction anymore. They're the challenges that drive the brilliant minds of today's space programs and the dreams of future astronauts. In this video, we're going on a wild ride through the future of space travel, exploring the mind-blowing technologies that could one day send humans to the stars and maybe even beyond our galaxy. So, buckle up, space cadets, because things are about to get cosmic. Hold on to your helmets, folks, because the next decade in space exploration is going to be absolutely wild. NASA's Artemis program is gearing up to land the first woman and the next man on the moon by the mid-2020s. And this time, it's not just a quick visit. We're talking about building a permanent outpost on the lunar surface, a stepping stone to further exploration. Imagine it. A lunar base bustling with astronauts and scientists, conducting experiments, testing new technologies, and preparing for even bolder missions. The moon will become our cosmic proving ground, a place to master the art of living and working beyond Earth. And while the moon is an exciting prospect, the ultimate goal, the holy grail of space exploration, is the red planet itself, Mars. Elon Musk and SpaceX, Jeff Bezos and Blue Origin, even NASA. Everyone's got Mars fever. Musk envisions a self-sustaining city on Mars, a second home for humanity. A bold vision, sure, but with the rapid advancements in rocketry and space technology, it's not as far-fetched as it once seemed. But before we pack our bags for the red planet, we've got some serious challenges to tackle. Alright, space enthusiasts, let's get real for a moment. Traveling to Mars isn't like hopping on a flight to Bali, it's more like sailing across the Pacific Ocean in a bathtub during a hurricane. Deep space travel presents a whole buffet of challenges that would make even the bravest astronaut gulp. First up, we've got cosmic radiation, those nasty particles zipping through space that can mess you up faster than a cosmic ray gun in a bad sci-fi movie. Shielding our spacecraft from this invisible enemy is crucial, and scientists are working on advanced materials and magnetic field technology to keep our astronauts safe. Then there's the whole zero gravity, making your bones turn into jelly issue. To combat muscle and bone loss, engineers are designing spacecraft with artificial gravity systems, spinning habitats that mimic the effects of gravity back on good old Earth. But perhaps the most daunting challenge of all is the one we can't solve with technology alone. The human psyche. Being cooped up in a tin can, hurtling through the vast emptiness of space for months on end, can do strange things to the mind. To prepare our astronauts for this mental marathon, psychologists are developing specialized training programs and even exploring the possibility of using hibernation pods. Imagine sleeping through the entire journey to Mars, waking up refreshed and ready to colonize. Let's face it, folks, the biggest buzzkill in the universe is the cosmic speed limit, the speed of light. It's the fastest anything can travel in the cosmos, and it's still painfully slow when you're talking about interstellar distances. With our current technology, a trip to our nearest stellar neighbor, Proxima Centauri, would take tens of thousands of years. So, how do we break free from this cosmic traffic jam? Well, scientists and engineers are hard at work exploring some truly mind-bending propulsion systems that sound like they're straight out of Star Trek. First up, we've got ion propulsion. It's a technology we're already using on spacecraft like NASA's Dawn mission. Ion engines use electricity to accelerate ions, creating thrust. It's incredibly efficient, but here's the catch, it's also incredibly slow. Next up is nuclear thermal propulsion, which sounds way cooler than it probably is. This technology involves using a nuclear reactor to heat a propellant like hydrogen to extremely high temperatures, creating thrust. It's a promising concept that could significantly reduce travel time to Mars, potentially cutting it in half. But if we're talking about interstellar travel, we need something even faster, something more elegant. Enter light sail technology. Imagine a spacecraft propelled by nothing but sunlight, its giant reflective sails catching photons like a ship catching the wind. With light sails, we could potentially reach incredible speeds, a significant fraction of the speed of light. And then there's the holy grail of space travel warp drives. So we've conquered Mars, we've set up shop, we're growing Martian potatoes, and the sunsets are surprisingly lovely. What's next? Well, my friends, the solar system is our oyster, and there are plenty more cosmic seashells to discover. Let's start with Europa, one of Jupiter's many moons. Europa is a fascinating world with a hidden secret, a vast, salty ocean beneath its icy shell. And where there's water, there might be life. Now, we're not talking about little green men here, but even the discovery of microbial life would be a monumental event. Imagine building underwater habitats on Europa, exploring the depths of this alien ocean, searching for clues about the origins of life itself. But if underwater living isn't your thing, don't worry. We've got other options. How about Titan, Saturn's largest moon? This intriguing world boasts a dense atmosphere, lakes of liquid methane, and even methane rain. With the right technology, we could terraform Titan, transforming it into a more habitable environment for humans. Think of it, vast fields of Titan wheat, methane-powered rovers exploring the dunes, and maybe even methane-based life forms. The possibilities are as limitless as the cosmos itself. Okay, space cadets, now we're getting to the really good stuff. Interstellar travel. Journeying to other star systems, exploring alien planets, orbiting distant suns. It's the ultimate adventure for humanity. But here's the catch. The distances involved are mind-bogglingly vast. Remember Proxima Centauri, our closest star system neighbor? It's over 4 light-years away, which means it takes light, the fastest thing in the universe, over 4 years to travel that distance. With our current technology, it would take us tens of thousands of years to reach Proxima Centauri. So how do we bridge these astronomical gaps? Well, scientists are exploring some truly mind-bending concepts. One of the most intriguing is the antimatter engine. Antimatter is like the evil twin of matter, and when they collide, they annihilate each other, releasing an incredible amount of energy. An antimatter engine could theoretically propel a spacecraft to a significant percentage of the speed of light, making interstellar travel a bit more manageable. Then there's fusion power, the holy grail of energy production. Fusion is the process that powers the stars, fusing hydrogen atoms together to create helium and releasing enormous amounts of energy. If we can crack the code of fusion power, we could potentially build spacecraft capable of reaching speeds far beyond anything we can imagine today. But what if we can't achieve near-light speed travel? Well, there's always the option of generation ships. Hold on to your hats, folks, because things are about to get really cosmic. We've talked about the Moon, Mars, even other star systems. But what about venturing beyond the Milky Way, our home galaxy, into the vast expanse of the intergalactic void? Right now it seems as impossible as anything we can imagine. The Milky Way is a whopping 100,000 light-years across, and even if we could travel at the speed of light, it would take us 100,000 years to cross it. And that's just our galaxy. The observable universe is estimated to be about 93 billion light-years in diameter and contains billions upon billions of galaxies. The distances are so vast, so incomprehensible, that they make interstellar travel seem like a walk in the park. But hey, remember when we thought flying was impossible? Or traveling to the moon? Humanity has a funny way of defying expectations and achieving the seemingly impossible. So, what would it take to become a truly intergalactic species? Well, for starters, we'd need to overcome some pretty significant hurdles. The energy requirements for intergalactic travel would be astronomical, pun intended. We'd need to find new, even more efficient sources of energy, perhaps harnessing the power of black holes or dark matter. Then there's the issue of time. Before we launch ourselves headfirst into the cosmos, colonizing planets and boldly going where no one has gone before, it's worth hitting the pause button for a moment of cosmic contemplation. Space travel isn't just about rockets and robots. It's about the future of humanity and our place in the universe. As we venture further into the cosmos, we're bound to encounter ethical and philosophical dilemmas that make us question our very understanding of life itself. What are the ethics of colonizing other planets? Do we have the right to claim ownership of worlds beyond our own, potentially disrupting existing ecosystems or even encountering alien life forms? And speaking of alien life, what happens if we're not alone? How would contact with an extraterrestrial civilization change our understanding of ourselves and our place in the universe? Would we be welcomed with open arms or met with hostility? Then there's the issue of risk. space travel is inherently dangerous. We're putting human lives on the line every time we launch a rocket or send a crew on a deep space mission. As we stand on the cusp of a new era of space exploration, one thing is clear: the future of humanity is inextricably linked to the stars. From colonizing Mars to searching for life beyond our solar system, our destiny lies among the cosmos. The journey won't be easy. There will be challenges, setbacks, and perhaps even moments where we question whether it's all worth it. But the human spirit, our insatiable curiosity and unwavering determination, has always propelled us forward, pushing the boundaries of what's possible. So, what do you think? Will we become an intergalactic species, spreading across the cosmos and leaving our mark on the universe? Or will we remain bound to our pale blue dot, forever gazing up at the stars, and wondering what might have been? The answer, my friends, is up to us. Leave your thoughts in the comments below, and let's keep the conversation going. If you enjoyed this journey into the future of space travel, don't forget to like, share, and subscribe to Science Fact Tech for more mind-blowing space content. Before we wrap up this video, I want to tell you about a tool which will help you in your online privacy. In today's digital world, privacy and security are more important than ever. Whether you're managing multiple accounts, running an online business, or just browsing securely, you need a powerful tool to protect your identity. That's where gologin comes in. Gologin is the best browser for multi-accounting. Gologin allows you to create and manage multiple browser profiles without detection. With advanced fingerprint protection, cloud-based browsing, and anti-detection technology, you can safely access websites without worrying about bans or security risks. It's perfect for freelancers, marketers, and anyone who values online privacy. Ready to take control of your online security? Click the link in the description and try gologin today. Stay anonymous, stay secure, and explore the internet without limits.